For adding and subtracting complex numbers, we kind of already did that in the warm-up, so it's pretty much like we did with combining like terms if you have a variable equation. So we're going to add and subtract the reals together, and we're going to add and subtract the imaginaries. A quick reminder, this is going to come into play later on in the notes, but this just seemed like a good time for it. The conjugate of a complex number a plus bi is a minus bi. And the complex conjugate of, for example, 6 minus 10i is 6 plus 10i. So let's try a couple addition problems here. So we're asked to add and subtract 4 plus 2i plus negative 6 minus 7i. The bottom one, 5 minus 2i minus negative 2 minus 3i. Whole lot of minuses going on there. Folks, because we did this in the warm-up already, I'd like you to take a few moments, pause the video, and try this out on your own. Okay, clearly you paused it. You didn't just wait for me to jump back into it. So we're going to add the like terms. We're going to add the real parts together. 4 plus negative 6i gives us negative 6, not negative 6i, just gives us negative 2. The imaginary parts, 2i, and we're adding negative 7i. So again, keeping in mind we're adding them together. So it's essentially 2 minus 7i, giving us negative 5i. Put a box around. The second one's got a whole lot of minuses going on. We got 5 minus 2i minus negative 2 minus 3i. Yikes. So we have 5 minus negative 2. So it's 5 plus 2 essentially, which gives us 7. Then we have negative 2i minus negative 3i. In other words, negative 2i plus 3i giving us just positive 1i. So 7 plus i. Folks, we're going to move on to multiplying. Multiplying these complex numbers are, pun partially intended, a little more complex. So we can multiply just like we've done with variable terms. We're going to distribute, distribute, distribute. The biggest thing we need to pay attention to is that I squared equals negative 1. We have not dealt with this yet, but let's talk about why that is. So going back to our definition for the imaginary by definition was the square root of negative 1. Now, if we were to take both of those sides and square it, so if we have I squared, it'd be the square root of negative 1 squared. Well, square roots and squares cancel out, so we just get I squared equals negative 1. So anytime you see square or I squared, I want you to think of replacing it with negative 1. Let's try this out. So 3 plus 6i times 4 minus i. So we're going to distribute just like we've done in the past. 3 times 4 is 12. 3 times negative i is negative 3i. And then we're going to move on to the 6i that is. 6i plus 4, times 4 is 24i. And then 6i times negative I. This is going back to something we talked about a little bit ago, where I want you to treat I like a variable for the most part. So 6i times negative I gives us negative 6i squared. Now going through and combining like terms, well, 12 has nothing like it yet. We'll come back to that in a second. We got the negative 3i plus 24i gives us plus 21i. Now this negative 6i squared, I want to do a sidebar on this a second. Negative 6i squared. We talked about I squared just in the previous slide. That's really negative 6. Wow, I'm having a hard time writing. Negative 6 times negative 1, which really gives us positive 6. So negative 6i squared, or minus 6i squared, is effectively plus 6. So let's copy that down here. So now we have 12 plus 21i plus 6. We add the 12 and the 6 together, we get 18 plus 21i. So again, pay attention, watch out for those I squareds. This next one, 1 times 3 is 3. 1 times negative 4i is negative 4i. Negative 4i times 3 is negative 12i. And negative 4i times negative 4i gives us positive 16i squared. Combining like terms that we can do so far, nothing's like 3 yet. We got negative 3i minus 12i giving us negative 16i. And then this plus 16i squared. Again, I squared is negative 1, so it's really plus 16 times negative 1. In other words, minus 16. So when we combine the 3 and the negative 16 together, we end up with negative 13 minus 16i. And I'll put a box around it.